Okay, rounding out circuits. This question is actually about household power and cost. And this is pretty sure this is one I did with my class as a warm up, but we're going to rank these three objects. So we've got these three appliances. We've got their current and their voltage, and then we've got the number of hours they're used per day. And we want to find out which one would be most expensive, which one would be in the middle, and which one would be least expensive. So the way we did this was we reminded ourselves that power equals current times voltage. Okay. And the cost is the same. We're really just coming up with a number we can use to rank each of these. So we could multiply current and voltage to get power and multiply that by the number of hours per day. That's really going to give us watts per hour, but that's okay because we're just doing a comparison. So I'm going to have 4 times 120 times 3 for the refrigerator. I'm going to have 8 times 120 times 0.1 for the microwave. And I'm going to have 9 times 240 times 0.5 for the stove. So for my trusty calculator here, let's see. 4 times 120 times 3 is 1,440 watts per hour for the refrigerator. 8 times 120 times 0.1, 96 for the microwave, not much. And then 9 times 240 times 0.5 for the stove, 1,080. So the refrigerator is going to be the greatest, and then the stove, and then the microwave finally there at the end. Okay, which of the following would always increase the flow of current through the lights in the circuit? Decreasing the battery voltage and decreasing the resistance. So that would increase current, but not the resistance portion would increase current, but not the voltage. We want to increase voltage. So remember, this is V equals I times R. If voltage increases, then current increases. So really, we can strike out these two where we're decreasing the voltage. We know we got to increase voltage. And then we also know that resistance and current are inverse. So voltage and current are direct. Resistance and current are inverse. So if resistance goes down, current goes up. So increasing the voltage and decreasing the resistance would increase current flow. All right, and then finally we've got just a table here to remind us about some things on series and parallel circuits. So with series circuits, we have one pathway. We've got one single path around. So let's say we've got a circuit with 2 resistors here. We've got one pathway that we're traveling. What happens when one element stops working? All stop working. Remember, we unscrewed one bulb and the whole thing went out. That's one pain about series circuits. The rule for current is that it's all the same. So I total equals I1 equals I2. We'll just write our rules for this little 2 resistor circuit here. The rule for voltage is that the total voltage is going to equal our voltage from our battery. I'm just making a little symbol for battery there. And then that's going to equal the voltage for each component. So each of these components is going to have some of that total voltage. And when we sum them up, we're going to get our total, which is also the same as what comes from our battery. And then resistance also just adds up. So here, my total resistance would be the values of this one plus this one. Okay. So series is more, remember that one was a little more simple and straightforward than parallel. Parallel, we have multiple paths. So instead of just one loop here, we're going to have two. Okay. And because we have multiple paths, if one element stops working, the others will continue working because they're on separate pathways. The current adds up, so each pathway has its own current. So here, this one maybe is I1, maybe this one's I2, and they're going to add up to give me my total current. My voltage stays the same, okay, because of the multiple pathways. The voltage, there's voltage for each pathway that's going to be the same as the voltage from the battery, and that's the same for each of the pathways. And then resistance is where we've got our 1 over equation. And so this is because we're still following Ohm's law. So as resistance goes up, our current goes down. As resistance goes down, our current goes up. Okay. So as we add more pathways, we're actually decreasing our resistance because we're giving ourselves more pathways to travel through. And that gives us an increase in current. That means as you add more and more resistors into this type of circuit, you're actually decreasing your overall resistance. And so we end up with this 1 over equation that we use to get total resistance. We can still use Ohm's law, and a lot of times we did that with problem solving if we could, just to avoid this kind of messy thing. But this is the rule for resistance for parallel circuits. So, all right, so then there'll be one more page, quick page on electromagnetism.